Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine for a moment that every tree standing in a forest is not just a biological organism, but a sophisticated, living hard drive. For decades, we have used tree rings to track the history of Earth's climate, identifying years of drought, fire, and abundance. But recently, scientists have discovered that these rings contain a record that extends far beyond our atmosphere. They hold the data of the cosmos itself. This is the emerging field of cosmic dendrochronology, where the growth patterns of ancient timber reveal the most violent events in the universe: gamma-ray bursts and massive solar storms. The story began in 2012 when a Japanese researcher named Miyake discovered something startling in the rings of ancient Japanese cedar trees. While analyzing the chemical composition of wood dating back to the year 774 AD, she found an unprecedented spike in carbon-14 levels. This wasn't a small fluctuation, it was a massive, sudden surge that defied traditional atmospheric models. Since then, several of these Miyake events have been identified throughout history, hidden in the wood of bristlecone pines, oaks, and cedars across the globe. To understand why this is revolutionary, we first have to look at the chemistry of a tree ring. Trees breathe in carbon dioxide from the air to build their wooden structures. Most of this carbon is carbon-12, but a tiny fraction is carbon-14, a radioactive isotope. Carbon-14 is created in our upper atmosphere when cosmic rays, high-energy particles from space, collide with nitrogen atoms. Under normal conditions, this process happens at a steady, predictable rate. However, when Earth is hit by a massive blast of radiation, the production of carbon-14 goes into overdrive. The trees then absorb this excess isotope and lock it into their growth rings for that specific year, creating a permanent, indelible timestamp of a celestial catastrophe. What could cause such a massive surge in radiation? The primary suspects are solar superflares and gamma-ray bursts. A gamma-ray burst, or GRB, is the most powerful explosion in the universe. They occur when a massive star collapses into a black hole or when two neutron stars collide, releasing more energy in a few seconds than our Sun will emit in its entire 10 billion year lifetime. If a GRB occurred within our segment of the Milky Way, the resulting flood of gamma radiation would slam into our atmosphere, triggering a cascade of chemical reactions and a monumental spike in carbon-14 production. The event of 774 AD is particularly fascinating because it aligns with historical accounts. Medieval chroniclers across Europe reported seeing a red crucifix in the sky after sunset. While some dismissed this as religious metaphor, scientists now believe these observers were witnessing the atmospheric aftermath of a massive cosmic event recorded in the trees. The radiation would have ionized the atmosphere, potentially creating vibrant, strange auroras visible even at low latitudes. By matching the chemical spikes in the wood with these ancient manuscripts, we are beginning to map a timeline of cosmic violence that predates modern telescopes. But why does this matter today? These tree rings serve as a sobering warning. The Miyake events recorded in the wood were far more powerful than any solar storm recorded in the age of electronics. If a similar blast of radiation hit the Earth today, the consequences would be civilization-altering. Our modern world relies on a delicate web of satellites, fiber optics, and power grids. A radiation spike of that magnitude could fry satellite electronics, disrupt GPS, and potentially collapse global power distributions for months or even years. By studying the frequency of these events in the tree ring record, researchers are trying to calculate the statistical probability of the next hit. Furthermore, this research is changing how we view the relationship between life and the stars. We used to think of Earth as an isolated bubble, but but dendrochronology proves that the trees in your backyard are intimately connected to the deaths of distant stars millions of light years away. Every forest is a library of galactic history, waiting for us to read the wood. As we refine our ability to detect these isotopic signatures, we may find records of even older events, perhaps even tracing the supernovae that helped trigger the evolution of life on Earth by altering our ozone layer and climate. The next time you look at the cross-section of a fallen tree, don't just see the age of the plant. See a cosmic sensor that has been quietly monitoring the depths of space for millennia. The universe leaves its fingerprints on everything it touches, and it turns out that the most reliable witness to the history of the stars is the humble tree. For more incredible facts like this, don't forget to subscribe and turn on notifications.